Okay, let's just dive right into this explainer. If you're out there building rich, interactive AI experiences, you already know that the leap from plain text to a fully dynamic UI, well, that's where the magic really happens. But it's also where things can easily break, right? So today, we're unpacking the strict protocols for building these experiences using LMDX Visual Components. We're going to figure out exactly how to prompt for them, how they actually appear on screen, and the absolute syntax laws we have to follow to get them right. This quote right here perfectly captures our foundational rule for today. Markdown is your default. Every component adds friction. Earn it. We aren't just making things look pretty for the sake of it. Whenever you decide to inject a UI component instead of just relying on plain text, you're actually adding cognitive friction for the user and parsing friction for the system. Every single visual, every carousel, it must be earned through real, concrete, informational utility. To get us there, here is a quick look at our roadmap. We're going to cover the LMDX syntax laws, routing images and carousels, mapping sequences and timelines, generating interactive widgets, and finally, guiding the next step. All right, let's hit that first one, the LMDX syntax laws. Okay, so before a component ever even renders, the AI's internal workflow has to follow this super strict pipeline. It assesses the query, it actively retrieves images if necessary, and then, and this is absolutely crucial, it leads with substance. You literally always answer the user directly with solid markdown first. Only after you've provided that textual substance do you actually enhance the output with LMDX components. And then you cap it off with a follow-up. Now take a look at the severity of these rules, because precision here is non-negotiable. If you mess this up, you trigger a fatal parser crash. No joke. You have to maintain a flat structure, which means absolutely no root wrappers. The line start law means every single component opening tag has to start on a brand new line. You cannot stuff components inside markdown lists or tables, and attribute safety? Lockdown tight. If you use a greater than sign inside a property, it will literally break the entire render, so watch out for that. Moving right along to part 2, routing images and carousels. It all kicks off with the image relevance test. You can't just toss in a random, decorative stock photo of a laptop because someone asked a question about software engineering. To pass this test, the visual absolutely must directly illustrate a core concept or a physical object. It needs concrete informational weight. We're talking about things like showing the anatomy of a plant cell, or maybe a very specific historical architectural style. If it doesn't actively aid in identification, comparison, or explanation, just stick to text. So once you actually pass that relevance test, you're faced with a simple binary choice. If you just have one primary subject, it gets a standalone contextual hero image component. But if you need to show a progression or you're comparing a few distinct visual subjects, you need to route to a carousel. The big constraint to remember here: carousels are strictly meant for 4 to 10 distinct subjects. They are used specifically to condense related information and keep the overall document length down. Up next is Section 3, Mapping Sequences and Timelines. It's actually really easy to mix these two up, but they serve completely different purposes. You deploy a sequence component for procedural data. Think step-by-step instructions or walkthroughs, where the exact order of operations is critical. On the flip side, you only use a timeline when actual dates and chronological history carry the informational weight. Basically, the shape of your data dictates exactly which component you reach for. Looking at this breakdown, which ties right back to LMDX Law 6, we see some very strict parent-child relationships. You can't just drop random text inside a sequence. It requires the exact stepchild element, which in turn strictly requires a title prop. Meanwhile, a timeline demands timeline event children, and those need both title and time props. You literally have to feed the parser the exact right data structure, or it just won't render flawlessly. All right, Section 4, Generating Interactive Widgets. This is where things get really fun. The Generate Widget component is an absolute powerhouse. It's exactly what you need when a user wants to explore a physics simulation or dive into a complex math formula. But check out these prompt rules. The widget has to be preceded by a direct text answer, and the widget data itself has to be a JSON object wrapped inside fenced code blocks. There is absolutely no inline placement allowed. It's all about protecting that user experience by building a solid text-first buffer. Inside that JSON, you're essentially building out one of 3 high-value archetypes. First, you've got the simulator, which lets users tweak parameters to see real-time physics results. Then there's the tool, which handles interactive math, where the user's inputs drive the outputs. And finally, the explorer, which hands the user full-blown data dashboards. It is just amazing how much educational value you can drive simply by structuring that prompt data correctly. Because these widgets are so distinct, you really have to architect their appearance properly on the screen. The height formatting rules are super specific here. A simple calculator gets a nice, compact 600 pixels of height. A physics or 3D simulation, that gets 700 pixels. And a massive, complex data dashboard earns the full 800 pixels. Specifying this ensures the user actually has enough visual breathing room to interact with the data without feeling cramped. When you are defining these widgets, there are some very strict standards to keep in mind. First up, data-driven completeness. Never, ever use placeholder dummy text. You have to populate it with real educational data. Second is styling delegation. The downstream UI is completely blind to your color requests, so don't try to hardcode colors or fonts. Let the system handle the styling. And third, contextual integrity. If a user actually gives you data in their initial prompt, you need to initialize the widget with that exact data. Don't make them start all over from scratch. Okay, our final section, number 5, guiding the next step. Here we have 2 mutually exclusive tools for closing out the workflow. You can either offer an ElicitationsGroup, which provides 1 to 3 exploratory paths for those broader queries where the user might want to branch out a bit. Or you can drive the user toward one single undeniable next step using the followup component. You have to pick one, and you are strictly limited to a maximum of 1 follow-up element per response, no stacking them. So let's just do a quick recap of our component showdown. Image and carousel handle your static visuals based entirely on volume. Sequence handles step-by-step procedures, while timeline handles your dates. We've unlocked the interactive JSON power of the generate widget, and we know exactly how to close things out conversationally with a follow-up or ElicitationsGroup. Sticking to these exact rules maintains those strict syntax protocols we talked about while genuinely elevating the user's learning experience. As you head back to your development environments, I really want to leave you with this thought. We've seen that LMDX Visual Components are incredibly powerful, right? But they require some serious discipline to prompt for and parse correctly. So before you wrap that next piece of data in a complex widget or a timeline, ask yourself, are you just decorating your text, or are you architecting a genuinely deeper understanding? Thanks so much for joining me for this explainer, and happy building!